Section 1.1 is all about functions. We're going to work with function notation, functions in context, and explore the domain of functions. I know you've worked with functions a lot already, mostly in Algebra 1 and Algebra 2. So this particular function that we're given on page 1 is in a table. So I'm going to expect you to read the text of the page, but I'm going to start reading right here for the video. So suppose we're keeping track of the population of an endangered species over time in an effort to determine whether conservation policies are having the desired effect. Let P of t represent the population of the species in thousands at time t, where t is measured in months since tracking began in January 2010. Values of p are given in the table below. So before we really look at the table, let's look at the function we're given. So p of t, and really the p, we could think of that as p with respect to t, or p is a function of time t, but p is our function. And again, if I think like, what does p stand for? It stands for the population of the species. So however many individual animals, or I'm kind of assuming it's animals, how many individuals are in the species. The other thing we want to be really mindful of is our units. So P is measured in thousands. So thousands of, I'm going to say of individuals. I really think that problem could be a little more clear. Are we talking about plants? Are we talking about animals? I'm just going to use the phrase individuals. All right, time, our other variable, and as far as calculus and possibly in physics as well, like we will pretty much always use t to represent time. So you don't always have to stop and explain that t is time, whereas any other independent variable we need to define. So t, time, is going to be measured in months. So be careful here, because months is not the variable, months is the unit. And really, months since tracking began in January 2010. All right, so that January 2010, that piece really just puts this in context for us. All right, we see that there's data in our table. So I'm going to jump down to this next part. We need to be familiar with the mathematical shorthand for describing functions. And I think a lot of this you are familiar with already. So what we are asked to do is two things. And in this class, it'll be really important that we read directions thoroughly and carefully. So for each of the following, we are asked to, 1, evaluate the expression, and then 2, explain what the value represents in terms of the context. Be sure to use correct units. So to make a very elementary example of this, when we talk about something in context, if you think of this as like in elementary school, we might have called this like a story problem or a word problem. In context is when we interpret the math in terms of the story problem. That's just the best way I know to articulate that. All right, so let's start with this first example. We're going to evaluate P of 0. And what I want to see anytime you do this for me is I want you to write P of 0 equals. So I know it's right there already on your screen or on your notes, but I still want you to write P of 0. And we'll come back to that later, but it's a communication piece for this course. All right, so P of 0 equals, we can go to our table, P of 0 equals 5.1. For the evaluate piece, that is all you need to write. We don't need to interpret. You don't need to say 5.1 thousand. You don't need to take that out and turn that into 5,100. It's just 5.1. All right, next we're going to explain what it means in context. And so when we're talking about a particular point in time, such as t equals 0, we're going to use the word at. So I'm going to say at t equals 0. And I'm going to talk about, I need to say the units. And to really bring this into context, I really need to say this whole thing, because this is the context of the problem. So at t equals 0 months, since, and I'm not going to say the since tracking began part. It wouldn't hurt, but I'm just going to say t equals 0 months since January 2012, or sorry, 2010. And then again, like, what is P? Because we want to basically say, well, P equals 5.1 at that time. So go back to the problem. P is the population of the species. So I'm going to say the population of the species. And the tense doesn't matter. You can say is or you can say was. I'm just going to say is. All right, so what is P at 0? Well, P at 0 is 5.1, but 5.1 what? Well, 5.1 thousand, and this is where the wording of the original problem I think is a little confusing for me, because it's not 5.1 thousand species, like those would be different types of species. I'm just going to say 5.1 thousand individuals. We know it's not people, it's probably animals. If you wanted to say 5.1 thousand animals, I think normally this would be clear. So, all right, so 5.1 thousand individuals. So when we answer in context, we've got to define both variables. It wouldn't hurt to say like when the time equals 0 months, or at time equals 0 months. But in calculus, you can pretty much you can pretty much get away with just saying t instead of time. But it is important that we have the units. It is important that we explain the variables in context, and it is important that we have the units, on both the time and the population. All right, I'd really like for you to pause the video and try the second example on your own, and then just unpause and check it. All right, for the second example, P of 16, again for that evaluating piece, P of 16 equals 6.0. So explaining that in context, what I would say is at t equals 16 months since January 2010, the population of the species is 6.0 thousand individuals. Usually a question that students have when we do this in person is they'll say like, well, hey, I sat down and I figured out what month it is. That's 16 months from January 2010. And off the top of my head, what is that? Well, it would be 2011, April maybe. Anyways, you can do that. Like, it wouldn't be incorrect, but the reason I just stay away from doing that is if you make a mistake, then it's wrong. Like if it's April and you say May, then it's going to be incorrect. So even though this doesn't sound good to our ears, this kind of very like scientific literal writing is something that we learn to do in math. All right, the next example is a difference. So when we have a difference, we're probably going to use the word difference. And anytime we're taking a difference, we're almost guaranteed to use the word between as well. All right, so if we evaluate this in first, I'm going to just do it over here. So P of 12 minus P of 3 is 0.5 or 1/2. Decimal fraction, either works. So now to interpret that in context. We know that if there's a difference between two things, that means something is changing. We might find ourselves using the word change. We might find ourselves saying that it increased or it decreased, but we need to address between which 2 points in time that difference occurs. And we need to move time forward. So what I mean by that is I'm not going to say between 12 and 3 months. I'm going to say between 3 and 12 months. So in context, I'm going to say between t equals 3 and t equals 12, let's say months, say like since January 2010. I'm just abbreviating for time here. And I'm sorry if there's noise in the background. I'm outside at my apartment right now and someone's like vacuuming their balcony, which is kind of strange, but whatever. All right, between t equals 3 and t equals 12 months since January 2010, the population of the species, and I guess let me just go back. When we took that difference and we got 1/2 or 0.5, we can tell that it's increasing. Like from 3 to 12, the population got bigger. So you can use the word change, which doesn't have a positive or a negative connotation, or we could use the word increased, which expresses that the population changed in a positive way. So let's see, the population of the species increases or increased, either one, by 0.5 thousand individuals. And if you're thinking like, hey, isn't that just 500? Sure, you can write that instead of 0.5 thousand. I usually stay away from, I like to use the original units, and it's just easier. You're less likely to make a mistake. All right, these last two examples on this page look really similar, and they are really similar. It's because they involve average rate of change. So if this structure looks familiar to you, if you think about it, it's like, I'm going to go off to the side for a second. In algebra, when you're asked to calculate the average rate of change, like say on a graph between 2 points on a curve, for example, we know this would be an x and a y coordinate. This point right here would also have an x and a y coordinate. And what you're really just doing when you find the average rate of change between this point where x is 1 and this point where we have x sub 2, you're really just calculating the slope of the line segment that connects those 2 points. So if you remember back from algebra, slope is just your change in y over your change in x. So when we go back to this problem over here, these are y values, so to speak, because it's the output. When we insert particular values of t to our independent variable, we get this output of p. So this should look to us like that y2 minus y1 over x2 minus x1. All right, so what I would like you to do is to evaluate these two, and then we're going to explore describing them in context in the next video. So between videos, just stop and do the evaluation piece, and then we'll get into the next part.